Good evening, mathematicians. Tonight we're going to look again at theoretical versus experimental probability. There are 16 green prizes and 14 red prizes in a bag. What's the theoretical probability of pulling out a green prize? What's the theoretical probability of pulling out a red prize? Well, we know that the denominator of our fraction needs to be the total number of possible outcomes altogether, and 6 and 14 altogether is 20. So for the green prizes, our theoretical probability would be 6 out of 20, but we know that we need to simplify and reduce this fraction. We can divide the numerator and the denominator by 2 since they're both even numbers, and we find that the theoretical probability of pulling out a green prize is 3/10. Now we need to figure out the theoretical probability of pulling out a red prize. Well, there were 14 red prizes out of 20 prizes altogether. We can reduce by dividing the numerator and the denominator both by 2, and we end up with a theoretical probability of 7/10 for the red prizes. So now, Jesse and Keith draw a prize from the bag 100 times. Each time they return the prize to the bag, their outcomes are recorded in the table. So it looks like Jesse drew 18 green prizes and 82 red prizes of her 100 times, and Keith drew 25 green prizes and 75 red prizes when he drew 100 times. This is no longer theoretical probability because we actually did an experiment. So this is our experimental probability. This is actually what happened. So now we need to figure out for Jessie, what is her experimental probability for pulling out a green prize? Well, she pulled out 18 green prizes out of 100. We can simplify, divide the numerator and denominator by 2, and we end up with 9/50. What about for Keith? Well, he drew 25 green prizes out of his 100 pulls, which is equal to 1/4 if we divide the numerator and the denominator by 25. Well, what about the experimental probability for the red prizes? Well, Jessie drew out 82 red prizes out of her 100 draws, which simplifies down to 41/50 because we can divide both the numerator and the denominator by 2. And for Keith, he drew 75 red prizes out of 100. We can divide the numerator and denominator by 25, and we end up with 3/4. So that's our experimental probability because it's actually what happened. Now, we want to figure out what was the difference between Jessie's theoretical probability and her experimental probability for pulling out a red prize. So if we remember all the way back to the beginning, the theoretical probability of pulling out a red prize was 14 out of 20. That's what should happen. And remember, we simplified this to 7/10. The experimental probability, what Jessie actually had, for her experimental probability, she pulled 82 red prizes out of 100, which we knew was equal to 41/50. So now we have to think, what's the difference between the theoretical and the experimental probability? Well, right now, we have two different denominators. We have tenths and we have 50ths. What we need to do before we can find the difference, or subtract, is figure out how we can get these two fractions to have the same denominator. Well, I know 10 can go into 50, so I might change this to an equivalent fraction where the denominator is 50. How did I do that? Times 5, and what you do to the bottom, you got to do to the top. So 7 times 5 is 35. Now I can find the difference. So her experimental probability was 41/50. I'm going to find the difference. That means I subtract 35/50. 41 minus 35 is 6. The denominator does not change when we do addition or subtraction of fractions. 6/50. I can simplify. I'll divide the numerator and the denominator by 2, and I end up with 3/25. So the difference for Jessie's theoretical probability and the experimental probability was 3/25. Now remember, the more times you do the experiment, the smaller the difference will be between theoretical probability and experimental probability. So if you do an experiment 1,000 times, this fraction would be even smaller.